Okay, in this video I'm going to show you how to use BindRest framework for creating our first application that returns hello world. This is going to be our first video, and later I will show you how to use more advanced features, and slowly you will be familiar with this framework and with all its capabilities. BindRest is a decorator-based framework, which means a lot of its behavior is controlled through decorators. And once you watch it, you will kind of find out what it means. First thing is, let's look at our TypeScript config file, tsconfig. This application framework requires that you use TypeScript to create your applications. So basically here you see it's just like a standard compiler options. Output directory is build. So it's going to build our project into a build folder. As you can see here, we don't have a build folder yet, but it will be created once we start a compiler. Okay. Next, let's look at a package.json. Here, as you can see, we don't have any dependencies here other than BindRest framework itself. And here I'm using a locally installed version of BindRest. And in the real world, you will just import this or install it from an npm repository. And I have a typings for the Node.js itself, so that our IDE will know how to handle Node.js owned functions and modules. This is the app.ts. This is the only file that we will be using to create our application. It's a standard file, which means that usually we'll just copy and paste it to create every application created with BindRest. This is how you create an application. Very simple. You create the app equals new application, and you pass some config parameters. There are other parameters available, but at the very least you need to define components directory. Here it takes an array of directories. Again, you can manually define strings here. I'm using this magic variable __ dir name, and basically it will be translated into a current directory when application starts. There is some console logs, which is not necessary, of course. I define a port number, and this is how I start the application. I call .init method, which runs initialization phase of the application. It kind of wires all the components together. It creates a HTTP routing rules, and I'm going to show you what it means. Basically, if you're familiar with Express.js, how you add in routes, you using like app.get, and then you put URL, which URL to listen to, and which controller going to respond to which URL. Here, it does this all for you, so you will never manually add any routes. This is done with decorators, and I'm going to show you soon. So init method, it may fail actually, because there could be some missing not dependencies, but your own, because this is dependency injection framework, which means one component that you create, it may depend on another component that you're supposed to create. So in case you forget to create your dependency somewhere, this init phase, it will actually do a lot of work for you at the start. It will analyze your components, and if everything looks good, it will start. If not, it will not start, and which is a good thing, because I would rather my application don't even start, rather than it starts and then fails while it's running. Okay, so this init method returns a promise because it does asynchronous operations. You may have a component, for example, that requires you to connect to a database, which is usually an asynchronous operation. And this is why this whole thing is asynchronous. So because some of your components may have initializers, which are special functions that return a promise. For example, like to connect to a database. You will see all this in a later videos, but so init returns a promise of request listener. Request listener is this handler, which is basically a instance of node own request listener. And if you're already familiar how Node.js works, a request listener is a function that takes request and response objects and runs some kind of a function and does not return anything, because its job is to get request parameters from request object and to write a response to a response object. And in doing so, it may have some asynchronous operations. All right, so then this is Node.js way to create a server. HTTP, as you can see, it's imported here from HTTP, which is Node.js module. So basically we create a standard Node.js HTTP server, passing the handler that we created from init, and we listen to port. So, and in case if it fails, we are going to log this error with a stack trace, and we're going to call process.exit. And the reason we do it is because the application, when it starts, it registered process event listeners. So it will know what to do on exit. And this is important because you may, for example, have a component that connected to database during initialization step, but then some next operation did not work in initialization, and then this whole thing failed. So the catch block will trigger process.exit, and the listener will then call your deinitialization methods that you register. And actually, you don't have to manually register anything, and application does it for you. So in short, it will disconnect, close your database connections, for example. Again, this is a little bit more advanced topic, but I will show all this later. So now let's start our compiler. As you can see, I think compiler was already started. So let's exit it. This is how I'm going to start the compiler, tsc-w. It means a watch mode. It's going to watch for a file changes. Whenever we change any .ts file, it will recompile. So application started, no errors. And if we go back here, we see a build folder is created, and we have our app.js. Now, this is IntelliJ IDEA, and I have pre-created a run configuration. Let's look at it. So basically, whenever I click on this run button, it will go to my work directory, to the build folder, and run app.js. That's all it's gonna do, run app.js. Also, it has this open browser, so it will open the browser that points to localhost and on the same port that we use in applications. So whenever I click on it, it will open a browser. So let's see what happens if I go now and click on it. Okay, so what happened is we got an error, but the good news is that we have a some good description of the error. And basically it says no controller component found. It makes sense, we haven't created any controllers, and it wouldn't make sense to run application without at least one controller, and that's why it's failed. So what are we going to do? We're going to create a controller. So the way we create a controller is we write a TypeScript file in our src directory. But the first thing we should do is create a folder. Now, there are no special requirements how to name your folders. But a good practice is to put your controllers in controllers folder, put your middleware in middleware folder, put your other components in components folder. Components are basically any type of classes that have your business logic. For example, maybe calculating something, or calculating the price or discount, or creating or finding a user in a database. So let's create a new directory first. We can call it anything we want. I'm going to call it controllers because it's just a good practice. And here I'm going to create my TypeScript file. I'm going to call it hello. Okay. And the way we create a controller, just like with any other component in this framework, it has to be a class. So controller is, as far as the framework is concerned, is a component, but it's a little bit special. So framework knows what controller can do that normal component cannot do, for example. Same thing with middleware. Middleware is also a component that can do some special things. So let's create a class. Class hello world, and we're going to export it right away because it has to be exported. Okay, now you can export it using default export if you want to, like export default but you don't have to. You can just export it as a named export, and it needs at least one method that will actually return a response. Now let's call it say hello. Again, the name is not important, it's up to you. Now it's a TypeScript, so we're going to indicate what type it returns. Well, let's do it later. So all we want to do is return an instance of a app response. I'm going to show it to you now and then explain what it does. Return new app response, and here like that. So app response can optionally take other parameters like a status code, for example, or response headers, but at the very least it must take a string of response body. Now there are also classes to represent a JSON response, and I'm going to show it to you in the next video. A simple app response just returns a plain text, not even HTML, just a plain text. And this is what we want to see right now. And it's going to use a default status code of 200. As you can see here, when I hover over it, because it's a strongly typed framework, it knows what parameters it takes. It takes body, a status code. Optionally, it's going to have incoming headers, which is an array, and array of response cookies if you want to return cookies in response. But in this example, we only return the string. So now we need to tell this framework that this method will be called when a request comes in with a get method, and when a request URI matches some URI. So the way we do it, we use a decorator, get, and it takes optionally a URI like this. I say optionally, I'm going to show you what I mean. We need to import this decorator from the framework like that. See? Right away, see, we have this squiggly line, so something is wrong. Let's hover over it and we'll see. So basically, the type of app response is not matching what it expects to be returned. So what happened here is this get decorator. It's actually kind of smart, because it would not allow you to add this decorator to just any function, but only to a function that returns a promise of app response. So simply returning an app response instance is not good enough. It has to be a promise of app response. Now, you can solve it two ways. You can say return, you can return, for example, promise dot, which is basically called immediately resolve promise. It's basically wrapping this whole thing into a promise. Okay, so now the squiggly line disappeared and all good, but you don't even have to do that because it's a TypeScript. There's another way to do it. It's up to you, whichever you prefer. All you have to do is add async. So TypeScript will, whenever it says async, it will automatically turn this return value into a promise of this return value. So now everything is fine. So what we should do, we should actually add a type annotation here. Return promise of app response. So now everything is fine. And the last thing left to do is to let our framework know that this is a controller. And the way we do it, we add controller decorator. Okay? And now we have to import it. Controller from bind rest, just like that. And this is it, right? So this is the minimal requirement to create a controller, a class decorated with @controller that has at least one method that returns promise of app response. So let's look at our build folder. Did we did not. It did not rebuild, I think. So let's look at it again. Build. Now it has controllers. Because this TypeScript watch mode, it has a little bit of a delay. So now it built, and now we can run this project. Click on run. Okay, now application started. As you can see here, we have an error. Resource not found for method get, which is great. But how did it do that? I mean, it's only because I did not put /hello. If I put /hello, this is our first controller, hello world. So everything worked. And the reason we get resource not found is because the framework comes with a default error handler. And if it cannot find the route, at the very least, you will get this error, resource not found. You can redefine your error handler actually, and you know, return some custom message or some image, whatever you want. But by default, it comes with this error handler for not found. Now let's go back to our project. You see what happened? We have a lot of debugging messages. Even though we did not actually log anything, as you can see, I don't have any console.log anywhere, but the framework spits out a lot of its own debugging messages like that, which are very, very useful, but there's a lot of them. And the way to turn them on and off is basically define an environment variable called debug. Let's look at here. You see here, environment variable debug, and it equals bind : star. So it basically means every debug message from the bind framework will be sent to console. And if you examine it, this console, you see we have bind rest runtime, bind container. So what this means, I can only enable specific debug message like bind.runtime, and I will only have runtime messages, or bind rest. So in our case, bind rest : star could be more useful, because just bind.star will also include debug messages from a dependency injection framework. Or I can turn completely off by deleting this environment variable, or like renaming it, apply, cancel. And now if I restart, stop and rerun, again I got this error. And if I look here, see, I have no logs at all. And if I go /hello, I get my response back, but there are no log messages. So this was our first hello world. As you can see, let's recap what we did. We basically created very easily a first controller using nothing but decorators. We did not have to manually wire any routing rule, for example, just like you would do in Express application. You would do like express.get and then put URI and a matching controller. And in Express, you would probably have to instantiate your controller first and export it here. It's all done for you. Now, of course, this was very simple example. What else I can show you is that this get decorator, it actually doesn't have to take this URI. We can delete it and will still work as far as that get is concerned, but it will, now you can define URI using path decorator. Again, another import from bind rest, and the path you would say hello. And what is the reason for it? Well, I mean, it's one extra line, right? So it was much easier to just put this path in .get underscore, I mean, yeah, at get decorator. But sometimes you may, it's up to you, you may have a requirement when for a controller to respond not only to get, but also to post, for example. So I can add post here, okay? And again, import post. So now my controller will respond to get and post as long as it's matching this path, okay? And that's the reason why the path can optionally be passed like this, or it can be passed as a separate, with a separate decorator path. Another thing you can do, you can add the path decorator on a class level, like this. And what it would do is if you have more than one controller, what it would do, it will match every URI that starts with hello, but here you can do a more specific path like /world. So now, in order for this to be matched, the URI must be /hello/world. Okay? And so, as you can see, it's very flexible. So you may have maybe, 5, 6 or more methods in your class, or your controller class, and they may all have a common URI prefix. Makes it very convenient to define it here on a controller, on a class level, and then more specific relative URIs here. Okay, so that was our first controller. So in the next example, we are going to show how we can pass parameters to our controllers. And parameters, we will be using query parameter. I'm going to show you how to use the path parameter. And we also can discuss cookie parameter, for example, or header parameters. And that's going to be our next video.